Hello, I'm Roman. Welcome back to the series of the videos, neural networks from scratch in Golang, as you can see, where we use a book called, Neural Networks from Scratch in Python, but yeah, we're writing everything with the Golang. I'm on the chapter of saving and loading the models and parameters, and as I told in the previous video that I will finish all the things that I needed to save and load the NIST dataset for the fashion, and so I would not bother you anymore with me writing some marshalling code back and forth. So I actually did it, and I skipped all of the things that are not needed for this NIST dataset. So we will fashion this one. So actually I implemented the serialization of the layer, and I think the most complex one. ReLU, softmax activation function, categorical entropy loss, categorical accuracy, and Adam optimizer. And how it looks like right now, I mean, in general, all of the things are kind of proxied between the actual model structs and what goes into the JSON, well, what goes into the Martian code. The only difference is I kind of give up with the Adam optimizer, because I mean, I just wanted to speed up a little bit, and I mean, that's fine for now that it's attributed with the JSON attribute, because like all of the things from the optimizer should be saved and restored back. So I decided just to annotate it and that's it, but the rest of the things are actually, custom, let's put it like this. So for example, first we are saving the model layers, and there are currently 3 different, how it's called? 3 different, not conditions, branches of the if statement. So we have the saving of the layer, saving of the ReLU activation, and the softmax activation. And basically I'm just checking the type. Where is this? So we have the type of item. Yeah, that's the story. So I'm basically checking the type of the item. If it's the layer, then I'm using the layer wrapper and adding to the layers wrap slice. If it's ReLU activation or the softmax activation, I'm just storing the type, because I actually don't need to store any of the data that lives inside the softmax and the ReLU activation. The only thing is needed is, understanding that it's actually this type of the layer. So I just, in the JSON, it will look like, can I check? Wait, assets model, this one. It will look like this. So you can see there is only one item, just type activation.activation ReLU, and that's it. Then there is a code for storing of the optimizer, and that's what I've been talking, that I still need to store type. Because during the unmarshalling, I will need to check the type first, so I would understand what concrete instance I need to create, because the whole model struct operates on top of the interfaces. So I cannot just unmarshal it, because unmarshalling wouldn't understand in which concrete type it has to unmarshal. And there is a data. So I'm writing the type of the optimizer. In this case, the only Adam is supported. And then I, marshal the actual optimizer. And that's it. This is how the JSON structure looks like. There is a array of the layers. There is a array of the layers. There is written what is the loss function, what is the accuracy, and there is a dump or optimizer, and we write it in a JSON, and that's it. Then marshalling is a little bit more complex and it, needs some love, um, but I will leave it like this for now and maybe do the refactoring a little bit later because there are some code duplications that I can move out. But basically, I'm loading the JSON into the map of strings and interface it, and then I'm going to one by one and typecasting it manually. So I decode the layers. If it's the map of the strings, if it's array of the interfaces, that's fine. Then I go through them and I'm taking one element. It should be, a JSON object that can be represented as another map. And then where the type field is handy. So I'm checking the type first. If it's the layer, then I do marshalling of the actual dense layer with loading of the weights and biases and regularizers. If it's the activation, I'm checking the type, then I'm creating the activation relu and adding into the model. Same with the softmax, and that's it. Then I'm checking, that could be generalized or at least moved into another function. So I'm checking the loss. If it's a category course entropy loss, then I'm creating it. Otherwise, currently I'll just return the error. And yeah, we'll just implement other types. It shouldn't be, probably it will be, just copy paste. Same with the accuracy. The categorical accuracy is supported for now. And there is an optimizer. Currently, Adam optimizer is supported, and it's actually, there is a trick because unmarshal takes the byte array, but when you subscribe, I typecasted it into map of the string and interfaces, so I taken the part of the JSON which represents the data for the optimizer, I marshal it back into the bytes array and then marshal. There is definitely a better way how to do this. I will research it, but for now, it solves the issue and, it happens only once during the loading of the model, so it's not that performance issue. And then I'm setting the loss value optimizer and the accuracy loaded. I'm calling the finalize because there are some things should happen before. And yeah, I'm calling the description and I'm returning the model. And that actually works. I've tested it only on this dumb model. I didn't check how it works. We will do this together, but if we make run, if we do the make run, you can see that this is the model that's description model that I created, and this is the one that was loaded from the JSON. There is still a question if I loaded the weights and biases correctly, and all of the things are but there is one thing is missing in the description, and that is, can I do this? Print accuracy. Do I have the name? No, it'd be like this. How it will look like. Okay. Okay. I will leave it for now. I will, implement it later. Because if I will start to implement this, I will need to implement it in all of the places, and I don't want to do this. So, what's the goal for today? The goal right now, at least, will be to train the model that we have for the fashion list, save it into the file, load it from the file, and call the evaluation. And the result should be the same. It could have some slight differences in floating point operation, but in general, it should be more or less the same value. So what do we do? I'm removing this. This is what I need now. To it inside this, and I will do import models. Okay, main/models, right? So what do we have? We have the data set, all of the things didn't change. We have the number of the batches. And then we have this evaluate for the model. And then we have evaluation of the loaded model against the same data. This is where it should be same, println. I will do something like this. So what we let's see. Basically, percent train. Ah. What? What? Where is it? Parsing train. What? Less assets. Okay. What you don't like? Okay. Land label changed. What happened? I mean, I didn't change this part. Okay. Fashion. All data sets. Not sure which one. Okay, training path. Okay. All data sets. Okay. I think I had this issue, but I thought it was fixed. Okay. Let's have the file path tier root path root path. What's not working? Okay. RAM ds store will be better. Yeah. Okay. Looks like it's working. So right now we're just waiting. And let's see. So it would be a success if the validation will be validation loss and the accuracy and all this stuff will be the same in the first try. But yeah, this is what I've been telling, that there could be a small difference between, but the accuracy is the same. The loss is a little bit different, but that's what I've been telling, that it's actually a success. So that works. It means that right now, if I will, for example, take a look at this one, pattern uses memory. Okay, so it's too big of the okay. I know, cats. Yeah. This is the model. lots of the values, but basically this, yeah, well, number of the inputs, it's like 10 by 128, but this is then 128 by 128, and that's the same. Actually, I'm interested in, you know, a less, no, do think age, right? 2.5 megabytes, 2.4 megabytes of the text. Of course, if I will, you know, load it, well, save it into the binary format, it would be less. But, you know, right now I don't really care about the size and optimization of the storage part. I don't have such big models. Yeah. And, you know, all of this is just an educational purpose. So what it means? It means that saying the full train model is common way to save the model, it saves parameters, blah, blah, blah. But I consider I'm done. And yeah, I actually need to commit all of the things. So I can show, yeah, load from params. Actually, the dense layer could be loaded from the specific params right now. That's, I've done this for the unmarshalling purposes. But yeah, for example, if I will need to, like, when I will do proper carving with the unit test, etc., that would be handy because I didn't have to use the randomization inside the initialize method. So what we have a dense, marshalling, test for it, layer the same. We have the model data provider that encodes and decodes into the JSON. We have basically nothing changes in the this one. Adam, yeah, right now has the JSON attributes makefile. Yeah, I built all of the tests, and we have changes in the model. So save load model is done, right? So let's see. The next thing will be actually to go with the prediction, and yeah, let's take a look what has to be built. While we often spend most of the time focusing on training and testing models, the whole reason we're doing any of this is to have a model that takes new inputs and produces desired outputs. This will typically involve many attempts to train the best model possible, save the model, and load the saved model to the inference to do the prediction. In the case of the fashionist classification, we'd like to load a trained model, show it never seen before images, and have it predict the correct classification. To do this, we'll add a new predict model method to model class. Note we predict X with the possible batch size. This means all predictions, including prediction on just one sample, will still be fed in as list of the samples in the form of the NumPy array, whose first dimension is a list of samples and the second is sample data web. Come on, what? Will be the list of the samples in the form of NumPy array, whose first dimension is the list of the samples and second is the sample data. Okay. For example, if you'd like to predict a single image, we still need to create a NumPy array mimicking a list containing simply a shape of 1 of 701 image. Yeah, same for the dense. Well, for this one, still be the same. Number of the features in a sample pixels per image theorem to evaluate it will calculate the number of the steps we plan to take. Okay, default value, prediction step, blah blah. Then we create a list, we will populate the prediction. We'll iterate over the batches, passing the sample for prediction forward through the network and populating the output of the predictions. After running this, the output is a list of the batch predictions, each of them in an NumPy array, and partial result may be predicted on a batch of the samples from the input array. Any applications or programs that will make use of the inference output of our model, we expect to simplify pass in a list of samples and back a list of the predictions, both in the form of NumPy array. Since we are not focusing on the training, we're only using batches in the predictions to ensure our model can fit into memory. We're going to get a return that's also in I didn't understand the thing, but okay. Output append. In this example, we see an output with a batch size of 2 and total 6 samples. The output is the list of the arrays, with each array hosting batch of the predictions. Instead, we want just one list of the prediction, no more batches to achieve this. Okay, this is just, Python stuff and the way it works. I actually will need to think how I will do this maybe I'll just return a two-dimensional slice and I will extract the output and convert it into float64 slice and return it as a slice, not a dense actually. It's Python stack. Okay, make our full prediction method. So basically this kind of what we have. And we can load the model and test the prediction functionality, right? Model predict x test 5. Looks like it's working. After spending so much time training and feeding the best hyperparameters, a common issue people have is actually using the model. As a reminder, each of the subarrays in the output is a vector of the confidences containing a confidence metric per class. The first thing that we need to do in this case is to gather the argmax values of these confidence vectors. Okay, recall that we're using the softmax classifier, so this neural network is an attempt to fit to one hot encode method where the correct class is represented by 1 and others by 0. So for example here it's this one. Could write the code to do this, but we have already done this in all of the activation function class. We have added the prediction method. Okay. Okay. Print first 5 predictions. Okay. In this case, our model predicts all class 0 and our test label were only class 0 as well. Since shuffling our testing data isn't essential, we never shuffled them. They're going in the original order like in our training. This explain why all the predictions zeros. In practice, we don't care what class number something is, we want only what it is. In this case, class numbers map directly to the names, so we add the following dictionary to our code. Okay, and then we just map results. Okay, this is great, but we still have to actually predict something instead of training the data. When covering deep learning, the training steps often get all the focus. We want to see those accuracy and loss metrics. Looks good. It works well to focus on the training for tutorials that aim to show people how to use a frame. But one of the larger pain points we see is applying those models in the production, just running predictions on the new data that was sourced from the wild. At the moment, we have a model trained on items of clothing, so we need something truly new. Luckily, you're probably a person who owns some clothes. If so, you can take a photo of those to start with, if not, using the forms. Yeah. And, then we need to convert it, load it, blah, blah, blah. That definitely will be the next thing. Let me check. Okay. Okay, so let's actually build the predict model. Well, first, what I want to do, I want to take this, right, and see if it actually makes sense. Data provider with Where is the data provider? Okay. This one, right? And defined lock, batch size, and the validation data. And we have to this. That should work, right? Validation xval. I'm just constructing DS tasting datasets, and okay, and this one. Data main slash data set, I think, right? Okay. Okay, so that's loaded. Because I already have a trained model, why do I need to train it once again? Okay, so there is one thing that we need to start building is a set finalize. I don't need this anymore. Model forward, backward, train. And well, let's pick evaluate. Okay, so we have one model, and that will be what's called inference, predict. Actually don't need the X, so there actually will be values, right? Okay. Input samples, it will be the dense, right? We need to have the batch size as int, and what it will return. This is the very good question. There are two options. The first one is to return the dense and then to work with, or I should return. Yeah, I think the predict will return the dense because based on the because in one case it could be it's a two-dimensional array. The row count represents the number of the samples, and the column count represents the number of the outputs. And for example, in a binary regression model, it will have one value. In classification, it will have several values. Same with the regression model, it will have one value per sample. And then, knowing the architecture, I will do the post-processing. So the predict should be kind of agnostic. Cannot use nil. Okay, maths new dense 0 0 nil. Okay. So we have the prediction steps. Prediction steps equals to 1 by default. If there is a batch size, we have this like this, right? The only difference is the prediction steps is calculate steps. How we do this? We use okay. I will do the model data X as input samples, Y as input samples. No, just because I'm still using the X only, and that's fine for now. So if we, okay, this is we calculated. Then we create a list that will populate with the prediction. And I don't know how to organize it for now. I will create it as, you know, output as actually new dense 0. No, actually, the question is the number of the outputs, right? I cannot understand it on the input samples. Because we'll take the output and then okay, I need to think. Basically, a step in range. This is kind of what we're dealing with. A step in validation, the prediction steps, make batch data. Okay, so how would do this? I will do the X as input samples, Y as input samples once again, and just ignore the Y. I don't need this. I only care about the formats. It's not training. And I have the output, which is dense one. So how would I store it? Maybe I just do this var output as dense reference, and then I return output. No. Then, for example, if output is nil, then I need to take the rows and calls from the validation output teams, right? Then what I do new dense as RC and nil. No, actually, no, I just copy. No, commands dense copy of the validation output. This is the first one. Init output from first, what's called from the first response, right? But else append more outputs. And this is the question how I would do this. So for example, I have the output and adds AB element. No, that's not what I need. What I have? Apply scale, maybe scale? Scale multiplies, no. Chronicle, no. Sub outer. Calculate the outer, no. No, but it's inside the answer arithmetic. Okay, what else I have? Sub copy grow. Grow returns the receiver expanded by R rows and C columns. If the dimension of the expanded matrix are outside of the capabilities, note that the receiver itself is not modified. It returns the new one. Mhm. Stack appends the rows of B onto the rows of A. I just, I see this. Marshall binary encodes the receiver into a binary form and returns the results. Basically, if I would like to marshal the model into the binary, it looks like I didn't have to create all the wrappers, etc. And okay, no, I mean, I now knew how. So, okay, we have stack. And this is really interesting how it will look like. Okay. Okay, I need to test it somehow. Okay, so for example, I have the A that is dense. No, for example, 3, 2, and I don't know, 3, 2, it's like 6, 1, 2, 3, 4, 6, right? Load 64. Go num math. No. Go num math. This one. Too many arguments. New dense. Okay, then we have 2 by 2, and then it will be 10, 30, 40, then, okay, that's B, and then I have C that is, and then dense copy of A, and then C stack A and B. Okay, and then fmt print maths formatted not C, right? Dimension mismatch. Where? Stack will panic if the two input matrices do not have the same number of the columns, or the constructed stacked matrix is not the same shape as the receiver. Oh. Okay, so I actually need to allocate the new one. So that will be new dense. It will be 3 plus 2, 2 nil, right? One, two, three, four, five. Okay, so I can actually use it. Okay, I don't need this. I don't need this. What it means? It means that I'm taking the and more output, right? So I have the output rows, output columns as the output teams, right? I have the new row, and yeah, I don't need this as the validation output teams again. Teams. I do create a temporary one for new dense, which will be R plus NR, OC, and dim. Then I do temp stack output, validation outputs. No, then I do output equal to temp. That should work, right? And then return the output. That's it. Okay. We stack. Okay, so this is basically okay. I need to try. There is a model predicts. So we have the test X, that will be the X val. Do I have the slice? Row. Something with rows. Thinking how I can. Row view returns. Okay, let's take the first one. Then can I do loaded model? Wait. Predictions equals to loaded model predict and test X nil. Okay. And okay, C equal to X val teams. Then what I do, mad new dance 1 C and this date, maybe row. Okay, X data. Can I do slice? Row view 0 T metrics. Okay. Come on, how I can take the first row? X val. Okay, row equal to X val. Okay, this one, no. And then row, this one, right? Okay, so it's actually X val, this one. Okay. T print math formatted text missing. Oh no. Predictions, right? Make run. Okay, so we basically have, I do randomization, so every time I run, there should be different results, right? Yes, because it will use different images, but 1, 2, 3, 4, 5, 6, 7, 7, 7, 7, 7, 7. Sneaker. Okay, so, and well, I can do multiple of them, but yeah, the only thing that's I actually need to label them, but yeah, that I will do tomorrow. But basically, yeah, I have the model loaded. Right now I'm actually interested to rewrite it into the binary representation because it looks like I can get rid of the many of the code because the dance actually has the implementation into Marshall in binary, which if I found out earlier, I would done it much faster. But hey, now I know how to do the custom marshalling in the Go, which is interesting. So yeah, in the next chapter I will actually try to use it. Maybe I will do, maybe I will take a photo of my load and I will actually try to predict it. But yeah, the only thing is missing is conversion from the predictions into the class. But yeah, that we will do this tomorrow. Thank you for watching and I see you tomorrow. Bye bye.